Chemical quantities and reactions. QUANTITIES.
Okay. So anyhow, a molecule is two or more atoms stuck together. Okay, a compound is two or more atoms stuck together, but they have to be different atoms. So therefore, O2, which is a diatomic molecule, would be a molecule because it's oxygen and oxygen. However, sodium chloride is two different types, so they would be an atom.
So molecules are two the same type?
Not necessarily. A compound can be a molecule, but molecules aren't necessarily compounds. Does that make sense? It's kind of like rectangle versus square.
Okay.
I can never remember. Is a rectangle a square?
No.
No. Square is a rectangle. A rectangle is not a square.
Yeah.
Same thing. A molecule is just two or more atoms. In a compound, they have to be different atoms. So compounds are molecules, but molecules are not necessarily compounds. If they're two different atoms, it's a compound. Molecules can be everything. Two or more atoms is automatically a molecule. If we're talking about compounds, they have to be different atoms. Does that make sense?
Yeah.
Okay, so now let's look at just a little bit of review. Sorry, did I go too fast? Anyone? Okay, so a little bit of review as to what a mole is. If we remember back to when we discussed moles to start off with, they are a measurement of matter, which means it's similar to when we count things, when we find their mass, when we find their volume. So if I can physically count you guys, and I can physically count that there are 25 of you in this classroom, right? I could physically take one of you into the lab and I could figure out your mass. And I could measure the volume of this room by measuring length and width and doing a little bit of math, correct? I can physically measure that amount of matter. However, a mole gives us a way to measure how much or how many. So it's kind of a silly example, but I have one remote, right? I can count this one remote, right? I could take it in the lab, I could find the mass of this one remote, correct? And I could then find the volume of it if I really wanted to, right? But let's say I had a box full of remotes, and it's sealed. I can't see it. Can I count the number of remotes in that box? No. Can I find the mass of one remote in that box? No. I can't it's a box. I know it's full of remotes, but I can't see them. I can't count them. I can't find the mass of them because I can't open the box. And so instead, we would go a roundabout way. We could figure it out. We could go measure the entire box, right? And then we could Google the approximate mass of a remote, and we could make a pretty good guess as to how many remotes were in that box, right? But are we physically counting them? No, so we're honestly making an educated guess, right? Okay, that's what moles is like. So let's compare a mole to something. Okay, in life, you use the idea of a mole all the time. When you say, I have a pair of shoes, how many do you have? Two. If you say, I have a pair of, if your mom tells you to grab a pair of pants, how many legs does it have? Two. Okay, so a pair means two. If I say I have a dozen donuts, how many do I have? 12. If I have a dozen cars, how many do I have? If I have a dozen oranges, how many do I have? 12. It doesn't matter what I put after dozen, correct? It always, always, always means 12. It doesn't matter what I'm talking about. I could be talking about brownies. I could be talking about people. I could be talking about chairs. A dozen means 12, correct? Okay, a mole is the exact same thing. I'm not telling you how much mass it has. I'm not telling you how much volume it takes up. I'm just strictly telling you how many you have. Now, if we compare a dozen donuts to a dozen cars, obviously the cars are going to take up more mass, right? Obviously the cars are going to take up more volume because they are much larger. However, we still have 12, right? All right, but to do this, we need to remember something called a conversion factor. Does anybody remember what a conversion factor is? we use conversion factors when we're converting from one type of unit to the next. Does anybody remember what they're equal to? Okay, conversion factors are equal to 1. So let's do an example. I think when we did conversions, can anybody give me an example of a conversion factor? Any conversion factor? 10 millimeters is equal to 1 centimeter, right? Another one would be, 1 meter is equal to 100 centimeters, right? If I go get a meter stick and I hold up a meter stick, it is 1 meter long, or 100 centimeters long, or 1,000 millimeters long. It doesn't matter because it's all the exact same amount of distance, correct? Okay, so there it doesn't matter. I could do 1 meter over 100 centimeters, or I could write 100 centimeters over 1 meter, but it doesn't matter because that technically still equals 1. 1 meter and 100 centimeters are the exact same thing, so they're going to be equal 1. That's why we can flip-flop them, because they all equal 1. All right, let's see if we can do a little bit of practice. So let's use that same one. Let's do 1 meter equals 100 centimeters. So let's say I'm trying to convert 12 centimeters. What arrangement of that conversion factor do I need to use? Which goes on the bottom, the centimeters or the meters? The centimeters goes on the bottom, and the meters goes on the top. Why? Because I need this unit and this unit to cancel out, and then we just do the math, right? What if I start with 12 meters? Then how am I going to arrange my conversion factor? The meters is going to go on the bottom. The 100 centimeters is going to go at top, again, because I want my units to cancel, right? Does everyone remember this? Okay. All right, so the first example I'm going to do is all about apples, just because we're going to learn how to write conversion factors before we're actually throwing the word mole. Okay, so when you go to the store, most of you, your mom says, go get me 5 apples, and you go and you physically count out 5 apples, right? But have any of you ever noticed at the store you actually have, there's like the spring scale pans? You can actually weigh them. That's usually how they're priced. The cashier puts them on the scale until it's so much per pound, right? Or if you know of an orchard, you could go to an orchard and you can buy them by a bushel. A bushel is technically volume, right? So there are 3 different ways we can buy apples. So let's look at this question. It says, what is the mass of 90 apples if 1 dozen apples has a mass of 2 kilograms? So first of all, there are 2 numbers in that word problem, right? I need to figure out which number is being converted and which number is part of a conversion factor, right? So which number is part of the conversion factor? 2 kilograms. 2 kilograms is part of the conversion factor. It's part of this conversion factor, right? Which leaves me with 1 number. This is the number that they are asking me to convert, right? And so the first step is to always write down what we're converting. So I'm going to write down 90 apples. Okay? Until we get good at this, I want you guys to go ahead and underneath it, I want you to write where we're converting to. So this one's asking me to convert to mass, right? And that way, as we're doing this kind of will help you signal to when you're done. Okay, because the hardest part about these problems is to figure out where you start and where you need to stop. So now we need 90 apples. Do I have a conversion factor, which are these 3 guys? Do I have a conversion factor that lets me go straight from apples to kilograms? No, because this is a dozen, right? So is there one that goes straight from one to the other? No, so I'm going to have to do maybe 2 steps. So the first one, the only conversion factor that has apples in it is the very first one, right? So am I going to put 12 apples on the bottom or 12 apples on the top? On the bottom. What's going to go on the top? 1 dozen. Okay, now I need a conversion factor that goes from dozens to kilograms. Does that exist?
Yes.
Yes. So 1 dozen is equal to 2 kilograms. Now, I know that we know a dozen is 12, so we could have skipped a step here, right? But do you think you're going to be able to do that when we actually get to the science part of this? No. So if you try to skip steps, just make sure you're doing it correctly. So our apples cancel out. Our dozen cancels out. We're left with kilograms, which is what we're wanting, correct? So now all we have to do is the math. So if you plug this into your calculator, I'm going to do 90 times 1 divided by 12 times 2 divided by 1. Now we don't actually have to do times 1 and divide by 1, right? But do you think those numbers are always going to be 1? No. So if I put that in my calculator, I'm going to get an answer of 15 kilograms. And that doesn't show up. I'm going to write it up here. 15 kilograms. And yay, we think we're done, right? But you remember the whole significant figure thing? We haven't had to do that lately. Why haven't we had to do that lately? Because we haven't done any math, have we? Have we been doing equations? No. We did chemical equations where we had to add coefficients, but have we been doing math problems?
No.
No. So therefore, we haven't had to worry about them. Well, math problems are coming back now. So don't forget about your significant figures. How many significant figures are in 90?
2.
1. How many significant figures are in 15? 2. So I need to round 15. Am I going to round it up to 20 or down to 10? Up to 20. So my answer is going to be 20 kilograms. And yay, looky there, we got the right answer. All right, now this one says you try, but I'm going to do this one with you guys as well. This one, it says, we are going to assume that 2 kilograms of apples is 1 dozen, and that each apple has 8 seeds. How many apple seeds are in 14 kilograms of apples? So there are 4 numbers there, aren't there? We need to just figure out which ones are conversion factors and which one is the one we're converting, right? So let's look at the first one. 2 kilograms of apples is 1 dozen. What is that? That is a conversion factor. So 2 kilograms is equal to 1 dozen, right? We keep reading and it says that each apple has 8 seeds. What's that? 1 dozen is 8 seeds. Not 1 dozen. 1 apple is 8 seeds. So 1 apple, 8 seeds. And then it says how many apple seeds are in 14 kilograms of apples. So what are we going to do with 14 kilograms? That's the one that we need to be converting, right? So the first step in conversions is to write down what you're starting with, and we're starting with 14 kilograms, right? 14 kilograms. And until we get good at this, I want us to write where we're going to. So where are we converting to? Seeds. Just kind of keeps us all on track. Okay? We need a conversion factor. We need a conversion factor that goes from kilograms to seeds. Does it exist? No. So what do? We need to do the kilograms because we need to get rid of kilograms first off. 1 dozen. Now, is there a conversion factor that goes from dozen to seeds? No. So what do? We can do 1 dozen, 12 apples, right? Because we all know that a dozen is 12. But do we want apples? No, we want seeds. So is there a conversion factor that goes from apples to seeds? Yes. 1 apple is 8 seeds. Okay? Our kilograms cancel out. Our dozen cancels out. Our apples cancel out. We're left with seeds. Is that what we want? Yes, so we are ready to do the math. So you're going to do 14 times 1 divided by 2 times 12 divided by 1 times 8 divided by 1, right? And you're going to get an answer of 672 seeds. Now, significant figures. How many does 14 kilograms have? 2. So how many can my answer have? 2. So how do I round 672 to 2 sixths? 670. And remember, the whole point of significant figures is you can only be as accurate as you're counting, right? So if he has 14 kilograms of apples, is it 14 exactly, or is it 14.1, or was it 14.3, or was it 13.9? We don't know. And so since he decided to round to a whole number, we have to do the same. Okay? Okay, now in this class, you guys almost, for the most part, refuse to show work. So I would like to remind you, is this a math class? No. Do we do math in here? Yes, but do I necessarily care about the right answer?
Yes.
No. Of course, it's part of the points, right? Of course, it's going to be worth part of the right answer, but if this problem was on your test, it would be worth 4 points. This would be worth 1 point, this would be worth 1 point, this would be worth 1 point, and then this would be worth 1 point. So if you do all that work in your head, and you tell me the answer is 670 seeds, you're going to get 1 out of 4 points, which is 25%. So you would get 25% in your test. Is that passing? No. If you give me all the other work and you accidentally put it in your calculator wrong, you get the wrong answer, you're going to get 75% of your points. Is that passing? Yes. So, unfortunately, I can't read your mind. I need to know that you know what a conversion factor is, and I need to know that you know how to arrange it. And the only way I can see that is if you write it. Okay. All right, so now let's start talking about moles. We've done lots of apples. Let's start talking about moles now. Okay. So apples. Can we count apples really easily? Can we find the mass of apples really easily? Can we find the volume of apples really easily? Okay, but let me see, remember back into that lab we did first semester where I gave you a jar of beans when we were learning about isotopes and I made you count the different and we had to figure out the percentages. Remember that? And you guys remember how much you hated me for making you do that? What if I would have given you a jar of sand? How much more would you have hated me?
Ooh.
Can you imagine trying to count the grains of sand in a jar? That would be pretty bad, correct? Could you do it? Yes. Would it take forever? Yes. Would you probably have a lot of human error in there? Yes. Okay. Well, think about how tiny a grain of sand is. That is still giant compared to how tiny an atom is. So can we physically count atoms? Can we physically weigh one atom? No. Can we physically find the volume of one atom? No. So just like when I was talking about the remotes in the box that's sealed, we have to do the same thing. We can't see them, so we have to measure them in a roundabout way. And that's what mole does, is it allows us to measure something we can see, measure something we can find the volume of, but at the same time figure out the number of atoms. Okay, so if I told you that that jar contained 6,000 grains of sand and it's half full, you guys could estimate 3,000, right? But you would have to have that conversion factor ahead of time, correct? All right, so a mole is technically a unit of measurement, right? Okay, it is a specific number of particles, and it is represented by 6.02 times 10 to the 23rd. What, Miss Tuckett? How do you expect me to remember that crazy number? Anyone? It's up there. It's on the box, up there on top of the shelf. I'm not going to take that box down because it's kind of hard to reach. It's kind of hard to put back up there. So it'll be up there the rest of the year. But if we look at this chart down at the bottom, the first one is an atom. So here we have an atom. An atom is one guy all by itself. If we have a mole of nitrogen, it is 6.02 times 10 to the 23rd, right? If we have a mole of the molecule nitrogen, which is 2 nitrogens, we still have 6.02 times 10 to the 23rd. If we have a mole of water, it's still 6.02 times 10 to the 23rd waters. If I have a mole of the ion calcium, it is still 6.02 times 10 to the 23rd. It does not matter what you put after mole. It is the exact same number. Just like it doesn't matter what you put after the word dozen, you still have 12, right? Therefore, when we're using mole as a unit, though, you need to be more descriptive. If your mom sends you to the store to grab something for her, she doesn't say, hey, can you go to the store and get me a dozen? You probably keep standing there waiting for her to finish the sentence, correct? Okay, so she would send you to the store to get a dozen donuts. She would send you to the store to get a dozen bagels, right? Same thing with moles. When you are writing your answers for moles, you cannot just put, I have 2 moles. You have to put, I have 2 moles of oxygen. I have 2 moles of fluorine. I have 2 moles of helium. So it's a 2-part unit. Okay? So, you guys ready to do an example? So now let's see if we can convert. So this is the part where I want everybody to make sure you're writing this down. There are 2 examples, 4 practice problems. I expect to see them all in your notebook. They will all be on your homework quiz. Okay? All right, so number 1 says, how many moles of magnesium is 1.25 times 10 to the 23rd atoms of magnesium? So first of all, does this problem give me a conversion factor? No. It tells me what I need to convert, but it doesn't give me a conversion factor. So it's wanting me to go to moles, and I'm in atoms. So I need a conversion factor from moles to atoms. So does anyone know what it is? Okay. 1 mole of anything is going to equal 6.02 times 10 to the 23rd. It could be atoms, it could be molecules, it could be ions, it could be anything you want to throw in there. So right now, we're dealing with magnesium, right? And in this question, it's asking us for atoms. So now I need to set up my conversion. The first step of any conversion is to write down the number you're converting. The number we're converting is the 1.25 times 10 to the 23rd. 0.25 times 10 to the 23rd atoms. Now, I think we're a little rusty on scientific notation in our calculators. So after notes, if you don't remember how to do it, I will help you. Okay? I'll help you figure it out. But we need a conversion factor now, right? Until we get good at this, I want you guys to write what you're converting to. We're wanting to convert to moles, correct? So I need a conversion factor with moles and atoms. Luckily, we just wrote it down up here. So what goes on the top, what goes on the bottom? 1 mole of magnesium is equal to 6.02 times 10 to the 23rd atoms. Okay, our atoms cancel out. We are left with moles of magnesium, which is exactly what we're wanting. So we get an answer of 0.20764111. I need to round that, right? Because you're not going to write all 12 digits out of your calculator, correct? How many significant figures do I get to keep? 3. This was the only number given to us right here. So I need to round this to 3. So what's my answer going to be? 8 moles of magnesium. Again, if you just put moles, I'm going to count it wrong. You have to tell me moles of something. And I know there's writing right there, sorry. All right, you guys ready for one more problem? Okay, let's try one more. Now we're going to try. Okay, first step, you need to write down what you're given, right? So, I'm going to try to squeeze this in at the top. We're going to start with 2. We're going to start with 2.12 moles. We need to go to molecules, right? The shorthand for molecules is MLLC. And then we need a conversion factor. What I always say to my head is I'm always going to put the unit I want over the unit I have. So I just always say put what you want over what you have. We want molecules. We have moles. 1 mole of anything is equal to 6.02 times 10 to the 23rd. And I know that's hard to read because I'm writing in blue. Okay, so my units cancel. We're left with molecules, which is what we want. So now we just have to put this in our calculator, correct? So 2.12 times 6.02. And I get an answer of 1.27 times 10 to the 25th. Okay, you have 4 homework problems. They're on my website. Okay, they're also at the end of the PowerPoint for those of you who like to download it off the internet.
I could put life if I solve that in real life. After Durant does some I saw a funny picture. It was Kobe and Michael Jordan. He's like giving Kobe he's whispering in his ear. He's like, "It's okay. We didn't need to switch teams to go to win the final or NBA finals." He was talking
The
to
homework
Brian,
will
he was like
needs to be
making fun of
completed in your
LeBron James
notebook,
switching teams.
and it will be part of your
We didn't
homework
need to switch
quiz next
teams,
week.
it's okay.
Are we ever gonna use like the 3 or is it just always 6 pointers?